Hello students, welcome back to the third video of this playlist. In this video, we will be solving question number 3 from one of the most recent past paper of 𝗙𝗵𝗱 Mathematics, which is the May 2024 F1 paper. So let's get started with the third question of the paper. So here in question 3, a function f of x, it's given as x cubed negative 5 square root of x negative 4x plus 7, where x is greater than or equal 0. The equation f of x equals to 0 has a root alpha in the interval 0.25 x equal to 0.25 to x equals to 1. Okay, so part A here is asking to use linear interpolation once on the interval 0.25 to 1 to determine an approximation to alpha, giving you an answer to 3 decimal places. Okay, so we have to use linear interpolation. Okay, so let's consider for linear interpolation the sketch of the curve. Let's try to figure out the sketch of the curve. Okay, it's not dotted line. Consider the sketch of the curve that would help you to understand. Okay, no problem, red color. Okay, that will help you to understand the interpolation method. Okay, since it's on the positive x-axis, so we will consider positive x-axis. Okay, so at first consider the value for f of x for x equal to 0.25. so let's find out f of 0.25. so f of 0.25, use your calculator to get the value. X cubed, I'm taking it into the calculator, f square root of x minus 4x plus 7. So we have to put 0.25. So if you put 0.25, you will get 225 over 64. This is f of 0.25, and f of 1, you can calculate it. 1 minus 5 minus 4 plus 7. So 1, okay, minus 5 minus 4, it is negative 9. Negative 9 plus 7, it is negative 2. And negative 2 plus 1, it is basically negative 1. Okay, so let's consider f of 0.25, it is 225 over 64. This is above the x-axis. This is just a sketch, so let's say this is the point. And f of 1, it is negative 1, so it is below the x-axis. Okay, so basically the curve will go like this, just a sketch. Okay, now consider the triangles formed. Okay, this is the triangle, and the point where the curve is intersecting the x-axis, this is x equals to alpha. Okay, now consider the triangle. Interpolation. For interpolation, the ratio of base and height, of this triangle will be equal to the ratio of the base and height of this triangle. Okay, so we will consider using linear interpolation. We can say alpha. Okay, they asked for the approximation of alpha. Okay, so x, let's say this point is x, so x minus this x value is 0.25, this is 0.25, so x minus 0.25 over its height, it's basically 225 over 64. 225 over 64 equals, this length is x equals to 1 minus alpha, that is 1 minus x over the height, it's basically negative 1, but we will ignore the sign for now. Okay, this is just 1, we are just considering the ratio. Okay, so now cross multiply, so x minus 0.25 will be equal to 225 over 64 minus 225 over 64 x. Okay, now take all the terms with x on the left side, so x plus 225 over 64 x equals to 225 over 64 plus 0.25. Okay, now make x the subject and get the value for alpha. Okay, the value for alpha, 225 over 64, not 4. 225 over 64 plus 0.25 divided by 1 plus 225 over 64. 1 plus 225 over 64 is from the left hand side. Okay, so you will get 241 over 289. So this is basically 0.8339100334. So up to 3 decimal place, we know we have to give the answer to 3 decimal place. So alpha, it is 0.834 up to 3 decimal places. That's the approximate value for alpha, and that's what part A has asked to find. Fine. Okay, next is part B. In part B, the question says the equation f of x equals to 0 has another root beta in the interval 1.5 to 2.5. Okay, so part B is asking to determine f dash x, the gradient function of f of x. Okay, so we have to differentiate f of x for that. So at first, let's make the power of the variable visible. Okay, so f of x equals to x cube. It has already power visible. So x cube and then negative 5x to the power half. X to the power half. The power would be half. Make the power visible, power of the variable. Okay, so negative 4x and then plus 7, if I'm not wrong. Plus 7. Okay, now differentiate. So f dash x would be 3x squared, right? We multiply the power with the coefficient of the variable. So coefficient was 1. So 1 times the power, it is 3. So 3 comes here, and then we subtract 1 from the power. So 3 minus 1, it is 2. Same goes for the second term. It will become negative 5 over 2 as we multiply with the power, and then we subtract 1 from the power. So half minus 1, it is basically negative of half. Okay, same goes for the third term. It will give negative 4 only. Okay, so f dash x, it would be 3x squared negative 5 over 2 square root of x. X inverse half is square root of x in the denominator, negative 4. This is f dash x, and that's what part B of question number 3 has asked to determine. Fine. Okay, next is part C. In part C, the question is asking, hence, using x naught equals to 1.75 as a first approximation to beta, apply the Newton-Raphson method. Okay, Newton-Raphson process once. It says once. We have to use the Newton-Raphson process once to f of x to determine a second approximation to beta, giving your answer to 3 decimal places. Okay, we have to approximate the value for beta using Newton-Raphson method. Okay, so basically the formula for Newton-Raphson method, it will be given in the formula booklet. Okay, so you can check it out from the FP1 part of the booklet. You will get it here, numerical solutions of equations. Here it says x of n plus 1. So we need x of the second approximation, x of 1, right? X naught is given, so we need x1. Okay, so x1 would be x1 can be written as x of 0 plus 1, right? So we will use this formula to approach our answer for part C. Okay, so for that we need to find out at first. Okay, let me write the equation for Newton-Raphson method. F of, okay, x of n plus 1. Okay, for part C, x of n plus 1 equals to x of n minus f of x of n over f prime x of n. If I'm not wrong, let me check. X of negative f of xn over f dash xn. F dash xn, correct. Okay, that's fine. We will use this formula from the formula booklet. Okay, for that we need when x naught is given, x naught is given as 1.75. 1.75 is x naught. then we need f of x0. So f of 1.75, because if you consider the formula, we need x1. So x1 would be x0 minus f of x0 over f dash x0. So we need f of x0. F of x0, use your calculator to get the value. The equation is x cube negative 5 square root of x negative 4x plus 7. Okay, now we need the value for f of 1.75. okay, so we need the value for 1.75. That would give you negative 1.25003278. okay, now f dash of x0, that is f dash 1.75. the equation for derivative, there is 3x squared minus 5 over 2 square root of x negative 4. okay, so we have to put 1.75 the value for x, so you will get 3.29767763. okay, now we need x1 equals to x0, which is 1.75 minus f of 1.75. so f of 1.75, it will become positive, minus minus makes it positive, 1.255 dot 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 over 3.297 dot dot dot. okay, so the value for x1 we have to find out. 1.75 plus 1.255003278 divide 3.297677635. okay, so this value is in the denominator and this value is in the numerator, so take the whole value to get the exact answer. okay, so that will give you 2.1305718.5. so how many decimal places they wanted? 3 decimal places. okay, so up to 3 decimal places the value for beta, so beta can be written as 2.131 up to 3 decimal places. That's it. That's the approximation for beta using the Newton-Raphson method. And that's the end of question number 3. Fine.